Please. First, thank you all for coming. This is the Dean's Distinguished Lecturer in the College of Engineering. My name is Bruce White. I'm the Dean. It's my pleasure to introduce a good friend of mine and one of the first students in our program in aerospace, aeronautical engineering back in the 70s, and that's Dr. Steve Robinson, Astronaut Steve Robinson. And I'm not going to say a lot because I know time and you'd rather hear him than me. But I do want to say a few things, that Steve is a unique individual besides being a UCD alumni, yay Aggies, and a very kind, good friend to the College of Engineering and Davis campus in general, making several trips, returning back and bringing Aggie memorabilia into space and returning it to the campus, which he's done this time, which will be coming out very soon. Steve's flown 4 flights, which is extremely unusual for an astronaut. Typically, 4 flights there's not many astronauts that have flown that. And that has to go to Steve's professionalism, his ability as an astronaut, and we just feel tickled that he is so kind to come back to us. He flew STS-85 in August of 97, 95 in November of 98, 114, STS-114 in August of 2005, and just recently completed STS-130 in February 2010, for a total of 1,156 hours in space, 20 million miles he's traveled. Well, it's actually 19.8, but who's counting? 20 hours of EVA outside walking, which perhaps you'll talk about a little bit today. And we're just so tickled that he remains a good friend to the college in many ways. With that, please join me in welcoming astronaut Dr. Steve Robinson.
Thank you, Bruce. Hey, Bruce. Dean White. He's still Bruce to me. How many students are in aeronautical aerospace engineering department right now?
In the department, there's about 600, and roughly half are in aerospace.
And the year I graduated was 1978, and there were 7. And we were all told, "You guys are crazy." So things have really progressed. I would like the room lights to be dimmer because this is going to be a fairly visual talk, and we'll have a little time for questions at the end. But this is mostly my kind of home movies about my most recent opportunity to go into space. I'm not going to state the obvious. I mean, there's a man who graded me down for sign errors. Sorry. There goes my job prospects. Well, there we have it. Okay. That's fine. No fire marshals in here, are there? Hey, when I'm ready for the a video, is somebody capable? Okay, great. That's great. So I'll show you some slides. I'll show you a little home movie that the crew made. We just finished it last week. But first, I want to give tribute to my really good friend, Tracy Caldwell Dyson, PhD graduate of UC Davis. This picture was taken about 4 days ago, and she has recently arrived on the International Space Station for 6 months in space. Now, the only reason I'm here is giving a talk is because she's unavailable. Wonderful person. We love her very much and respect her a lot. She's an amazing person and will do the space station a lot of good. All right, we'll talk about the Crew of Endeavour. This was the last big construction mission for the International Space Station. It's almost done. And we're basically the contractor that came up to put the new room on your house. We showed up on time. I'll introduce you to the crew. On the left there is the commander, Marine Colonel Test Pilot George Zamka, making his 2nd flight in space. And on the right is Air Force Colonel Terry Virts making his very first flight in space. There's Kay Heyer, who's a Navy captain in the reserves, but has also been with NASA for 15 years and making her 2nd flight. good friend of mine. We were in the same class and started at the same time. That's the best Aggie on board. Here's Dr. Nick Patrick with a totally typical expression on his face. Nick is an MIT graduate and making his second flight as an astronaut. There's Bob Benkin. He's a Caltech guy making his second flight. He's also active Air Force and great engineer. I've skipped the entire over a year of training here, so we get to the picturesque parts, but it's a pretty arduous year. You spend a lot of time away from home. You train for very long hours. You get to know each other really well, sort of for good and for bad. You see how each other is like, how you behave and how you react to stress when you haven't had any sleep and you don't feel well because you've got a cold and you didn't get lunch today and you're tired of rubbing elbows with the same person day after day. That's what training is like. But I'll tell you, it really works because when you finally get up in space, you really know each other. I mean, it's even, in some ways closer than family. Launch was spectacular. We launched on February the 8th. We tried on the 7th, but the weather kept us down, so we got all strapped in and then didn't go. Tried it again the next day. It was a little after 4 in the morning in Florida, and it was just a spectacular launch. We went through a little cloud deck. See that little cloud layer there? I'll show you a movie of what it looked like to go through there from inside. You never saw clouds go by so fast in your life. After we get up there, as you know, how the space shuttle works, it has a fuel tank to power the 3 engines that are on the shuttle itself. And so once we get up into orbit, we're not using the engines anymore, and the fuel tank's out of gas. So we release it, and it's got a timed valve in it that vents gas into space to make it tumble. And that increases the drag of it. There's a little bit of atmospheric drag even way up there and makes it fall down more quickly into the atmosphere where it disintegrates. So that's the venting going on right there. There's our ship. There's Endeavour. Excuse me. With our what we call our payload, which is a new part for the International Space Station, the last big chunk from the U.S. side going up there, called, poetically, the Node 3. We did have a contest to name it. Tranquility, I think, was the name for it. And you can see it's pretty big. It's about 15 feet across. It's almost 25 feet long. And it's got that thing sticking out the end of it, which won't stay there. But that is a kind of a domed window observatory, 7-windowed little module. It's actually not that little. It just looks like that. And we're going to take it off the end and put it on the kind of the side of the canister facing the Earth. This was a wonderful thing. The space station is huge, and it's yours. You've paid for it. American taxpayers have paid for not every bit of it, but most of it. It is international for certain, though. The main part of it, the habitable part where the people are, is kind of a long, sort of linked together set of canisters, pressurized canisters. And about half of those canisters are built by the U.S. and the other half by the Russians. And then off to the sides are laboratories. To one side, there's a huge Japanese laboratory, and to the other side, there's also a large laboratory built by the European Space Agency. So this thing is really cool. It's as if you're going through different sort of cultural influences on spacecraft engineering when you go from module to module. When we got right up close to the space station, after a couple days after we launched, it takes a couple days to kind of catch up and get close up to it, rendezvous it. First thing we did in space was inspect ourselves with a robot arm, and then when we got close to the space station, we let them inspect us. So we got right up close to it, turned over, showed them the sensitive part, the delicate part of the space shuttle, which are the heat shield tiles, which you could damage pretty easily. They took a series of high-resolution photographs, actually all over the bird, to take a look. This is actually a pretty good view of the various type of rocket engines on the space shuttle. The The three big ones are called the main engines. They are the ones that are fed from the fuel that's in that big red tank. So after the tank drops off, they're completely not used. Excuse me, I got a little pollen in the air these days. Above the main engines, those two sort of middle-sized ones are called the orbital maneuvering system engines. Those engines were built by Aerojet, Sacramento, and they've never known a failure. And they are used for a number of things, most importantly for coming home. When you're in orbit and you need to come home, what you have to do is reduce the perigee of the orbit, the low spot in the orbit. To do that, you slow down a little bit. To do that, you turn around so the engines are sort of into the wind, as it were, and you fire those two orbital maneuvering systems engines, 6,000 pounds thrust each, for a couple of minutes. And that slows you down enough to drop your perigee into the atmosphere and then use atmospheric braking for the rest of the time to slow down and then basically fall into the atmosphere. Then you see some little rocket bells, and those are part of what are named the reaction control system, which is just a series, I think it's about 46 small rockets around the shuttle that help the shuttle, or enable the shuttle to change its own attitude in orbit. And there's an even smaller set of those that you can't see. There's big ones and little ones. Once we docked with the space station, we had, there were 6 people on our crew, the shuttle crew, 6. Normally it's 7, but the Node 3 and the cupola weighed so much, we actually had to not have a full crew. So we had 6 busy people, and we met up with 5 folks on the space station. Now here we are, all in control and well ordered. And here we are, as we usually are, just flying around. So this is just the Crew of Endeavour. And this is my favorite picture of the crew because it really shows the nature of how we approached this, which was work hard and have a great time. I'm going to go through just the objectives here. Excuse me. These are actually prioritized objectives. It's a little bit of NASA-ese here, but I love this stuff, so I'm going to talk that way. The first thing we had to do was bring up a bunch of cargo for the space station and water. Now, this is kind of interesting. The space station has no way of generating water. So all the water that it has on board has to come from the ground. It does have a recycling system that takes water out of the air and your bodies to recycle into usable, potable water. But new water has to come from somewhere else, and so we bring it. And the way we get water from the space shuttle is the space shuttle's electrical systems are not batteries, they're not solar arrays, they're hydrogen-oxygen fuel cells, where you put together the H2 and the O2, you get H2O, you get a free electron, you get some heat. And with that H2O is absolutely pure water, and we collect it, put it in containers, and bring it over to the space station. High on the list was installing the new room for the space station, which I'll show you what we did with it. Again, a view of the Node 3 and the attached cupola as it's in the payload bay of Endeavour before we reached down with the space station robot arm and pulled it out and attached it. Here it is on its way, looking out the aft window of the space shuttle. That's, I guess I took this picture of the robot arm pulling Node 3 out of the bay and over to the space station. And these are kind of hard to see here, but this upper left is where the Node 3 is attached to the space station. Look at all those wires and cables. And this is an interesting engineering decision that was made long ago, which was the mechanical parts of the space station coming together are done using remotely controlled motors and latches and linkages. And so the sealed parts that make up the pressurized volume are all done that way. However, the rest of it hook up the fluids and the data and the cable and the heaters and stuff like that, whether they're hooked up inside or outside, are almost all done by hand. And so on the outside, our 2 spacewalkers, Bob Benkin and Nick Patrick, went outside 3 times to finish the hookups on Node 3. So once Node 3 was attached and we started working out the whole activation, again, it's like putting a room on your house. Once you build the structure, you still got to get the the electrical power and the lights and the heat and the air conditioning and the plumbing, and this is exactly what we were doing. That canister that was in the payload bay didn't look that large or impressive from the photographs, but here's what it looks like from the inside. It is very large, and the amazing thing was how empty it was. And so when we first opened the hatch, and I got to open the hatch the first time, and we went in there, and we had our masks on and stuff, and it was dark and musty, but it was pressurized. And it was just huge, and you could be in the middle of a volume, huge meaning about 15-ish feet in diameter. But that is large enough that you can be in the middle of the volume and not be able to touch anything. Well, then what do? You're just floating. And so, you try swimming and wiggling around. It's a pretty interesting experiment in dynamics, free dynamics. Most of the mission was spent with tools in our hands, and that was a great thing. It was great to be working in space. I mentioned the cupola moving from the end of Node 3 to the Earth-facing side of Node 3. Here's some pictures of it up with the robot arm. That process going on. The space station is really complicated, and it's also a sealed control volume that people live in. So CO2 has to be scrubbed out of the air. Oxygen has to be replenished. Nitrogen has to be replenished. Waste has to be dealt with. The water issue I talked about. Heating, cooling. Heat doesn't rise in space, so you have to have this active cooling for everything. Cooling inside the space station is done with water, pipes of water that go through heat exchangers that exchange heat either with air or directly with electronics boxes. Outside, the working fluid for the cooling system is ammonia. And so the big hoses that had to be hooked up on Node 3 were actually ammonia lines. We had some scientific payload operations that were really minimal. We were mostly the blue-collar construction crew trying to put some of the final touches on the space station so that scientific experimentation can really start to hit its stride in the next couple of years. I mentioned Spacewalks. We call them EVAs just because we like unpronounceable acronyms. Well, 3 of those were done. My job, I did Spacewalks on my last mission, so this time it was somebody else's turn. My job was on the inside, being sort of like the air traffic controller for them. So I had the procedures and talked them through it, and it's a very tight-knit 3-person team to always do these. So it was something I'd never done before. I really enjoyed it. Inside the airlock, there's Nick on the left and Bob on the right getting ready for spacewalk number 3. While they're in the airlock, we stuff them in this little airlock. You'll see that in the movie, and close the hatch on them. It's just full of spacewalkers. There's hardly any room in there at all. So when you look through the hatch and get a picture, this is all we got, which I thought was pretty neat. Once outside, of course, it's a different world for those guys, and you can kind of get a hint of the complexity of the space station just even in the reflection of the visor here. One of the amazing things about doing a spacewalk is you can do stuff like this and not feel like you're about to fall 220 miles. I'm not sure why that is, but it doesn't feel like it looks very often. EVAs were very successful. We had a couple of surprises, like you always do, but we had unusually smooth spacewalks, and it really goes to the planning from the teams on the ground that planned these things and then trained us to do them. Things went pretty well. Things got really complicated after a while, where once we had this new room on the space station, then we had to fill it up with stuff. And the stuff were many of the machines that deal with the environmental control and life support, and also exercise. So there's the hygiene compartment in there, water recycling machine, oxygen generator, a huge resistive exercise machine. Did you know that space station astronauts exercise 2.5 hours a day? How buff would you be if you did that? Lots of cargo and stuff. This is a brand new spacecraft, and anything that gets launched on the shuttle has to have a whole bunch of structure and bolts and stuff to keep it together during the launch loads. both the 3 Gs that it undergoes on the way up, but even more so the vibrational, the shaking, which can be very violent. So once we got it up there, we had to take out roughly 1,000 different bolts. And as it turns out, mostly taking out bolts isn't too hard. What you do with them afterwards is a lot harder, because you can't just put them down. So you put them in these plastic bags. And I realized once again that if you have a plastic bag with 100 things in them, and you open it to put number 101 in, you imagine what the rest of the guys are trying to do. It's amazing how much they want to come out of those plastic bags. And, you know, you'd be using your teeth and all your fingers and everything else to try to get this thing in there. It's a lot of work. Access for some things was pretty challenging, so we had to use all kinds of tool extensions, and it was great fun. Sometimes the lighting was pretty minimal. We didn't have the lighting totally up and running in the module, so you see us with these very fashionable headlamps on a lot of the times. The cupola itself has, again, all these utilities. It has cooling, believe it or not. It has communications. It has heating and power and electricity and data. One of the reasons is this isn't just made for looking out the window. It's made for doing robotic operations. So the space station robot arm is controlled by 2 hand controllers and a whole bunch of monitors. And that whole robotic workstation that you control it with is going to be moved into the cupola so you can actually look out the window and see the arm in 3D. Kay spent seemed like about a third of the mission in the cupola, turning wrenches and working procedures. The procedures we had to accomplish in about 6 days here was about just under 800 pages of dense, it looked like one of those Chilton's engine manuals that you had to work every page. So there's the view looking up into the windowed cupola. Terry with his little surgeon's kit of tools. Another couple things we did was reboost the space station. As I said, it's not completely zero drag up there. It's up in the upper fringes of the atmosphere, but it's up there all the time. So just even the few molecules or atoms of oxygen that it runs into drags it down a little bit. So we used our thrusters on Shuttle Endeavour to actually boost the entire space station up. And that was impressive because our total mass together, Station plus Endeavour, was just over 1 million pounds of stuff. When we undocked, we did a fly around, meaning we did an inspection circuit of the space station that I'll show you some great pictures of. Added to the mass by about 33,500 pounds. A couple of shots of the cupola here. Nice place for a crew picture. Of course, if you look at the other end of that, which is normally what you saw when you came up to it. It was even better than we expected. It was actually better than doing a spacewalk out there because the helmet really restricts your peripheral vision. When you're up there in this dome of windows, you really have a sense of the three-dimensional sense of the world and its motion. And you know, my feeling was, so this is what it looks like in space. And it took me my 4th trip to finally get to that realization. We didn't get a lot of time to look out the windows, but we took away some of our sleeping time to do that. It faces down towards the Earth. So the view is about as good as it can be. See beautiful things, bits of sunsets in the horizon. You can see that thin atmosphere there. The Russian Soyuz and Progress cargo vehicle. Looking across Endeavour, it was kind of neat to come up to this window and look down at our spacecraft, because when you're in it, you don't see it. The last we had seen of it was standing at the launch pad in the dark, looking up at this big, kind of groaning, hissing machine. And now we're looking at it in the peaceful setting of space. Just beautiful. Oh, a combination of passions here. You know, very lucky to to have gotten to do this. A couple of us who play guitar got together a few years ago and bought this guitar and sent it up to the space station, so it lives up there now. And I had a nice little half an hour one morning. Some people brought this up. We're not sure who designed the cupola exactly. It's traditional to stick your mission sticker up on one certain panel there on the space station. There's our commander, George Zamka, performing the honors. Space station was even bigger when we left it. Moving away, the solar arrays, it's a shadow of the space shuttle on the solar arrays. It's kind of hard to believe that human beings actually built this amazing looking thing. And the light kept changing. We went around it, but the sun was, of course, moving rapidly too. And so the light kept changing on it, and the view is just changed all the time. It always looked different. And there's a sign of a successful construction mission, a space shuttle with a completely empty payload bay. Moving away from the space station, off into the sunset. And we got a minute to simultaneously break the rules of both fashion and photography here. Had a little fun with optics. We also got a chance in between leaving the space station and coming on home, which was a couple of days, to inspect our spacecraft one more time and squeeze in a few photographs of good old planet Earth. Just go through these quickly. If you're an artist, space is a great place to be. The one drawback is you wish you could hold still sometimes. You're going 5 miles a second, and all these scenes go by too quickly. This is the Himalayas. South Pacific thunderstorms. It's over North Africa, somewhere out in the ocean. Mountains of northeastern Tibet. Dust storm over the Sahara. Probably my favorite thing to see in space are the colors of the atmosphere and how thin it is. If you're a student of weather, and every aviator is, it's fascinating to see weather on this scale. You never see this much of it at once, and you can see physical processes that you never really realize when you're down in the atmosphere flying in it. It's in Australia, or Mars, depending on what you believe. We're coming up to a movie here, which is, as I say, sort of our home movie that the crew put together. It's not all that professional, but it's what we wanted to show. So we're sort of starting, I'm ending the mission here. I'm going to start it over again in the movie. We landed at night. Boy, were we sleepy, but we actually are holding each other up in this picture. You never realize what a challenge it is to be a biped until you come back from space. Oh yeah, and then there was one last thing to do. As soon as I got out of the space shuttle, I got hauled off to this little room where they strapped me into this gear, and that piece of equipment rotated at twice per second for 45 minutes. And I was walking okay before that. All right, let's run that video. I think it's going to be on a different screen, right? Is that going on this one? Okay, good. Okay. Oh, the idea of that chair is to look at the readaptation of your vestibular system, the system that allows you to walk on only 2 feet. What you're trying to do, those things over my eyes are eye trackers. And it turns out your eye moves sort of in the inverse signal of what your vestibular system says your head is moving. So what you can do to study the brain is study how the head moves, watch the eye motions, and you have kind of a transfer function of what the brain's doing. Talk just a little bit about the training here. One of the kinds of training we do that we just love to do is fly these supersonic jet aircraft. They're old airplanes maintained perfectly by the folks at NASA. We spend a huge amount of time in simulators. I think more time than we spend at home. And this is a Rendezvous Simulator. It's mostly in the dark here, but you can see we're all crowded together just like we are in space. Going underwater to practice the spacewalks. You've all seen pictures of this. This is a kind of a big process. You show up early in the morning, get suited up, spend 6 hours underwater. So after lots and lots of that training, and most of it's in classrooms and sitting in front of diagrams and stuff like that, but we don't show that because it's kind of dull. So they got us up at some ungodly hour in the morning at Kennedy Space Center in our little dorm there, strapped in. On the lower right, you'll see a picture of the crew. That's me. There's the cloud deck. Solid rocket booster separation. Big flash in the cockpit. And after those guys are off, it gets a lot smoother. But the G's build up because you're getting lighter and lighter with the same thrust. Now, if you watch carefully, you can watch us go 0G right there. Now we're floating. Went from 3G to 0G in about 1/4 of a second. Boy, does that make your head feel weird. Remember that tank coming off? We're done with it. It's out of gas. So all kinds of strange-looking things happen, and finally the tank drops down. Shuttle Endeavour flies away. A couple of pieces of ice floating away there. And we flip all the way over so that we can photograph it and see if there was any foam that might have come off and damaged the shuttle. As it turns out there wasn't. So here we are in day 1, floating around, moving our heads real slowly. First thing we do is inspect our ship. We do that by taking the shuttle robot arm. We're not on the station yet. We're out on our own. We have a big, long extension, so we have 100 feet now of robot arm, and we go all the way along, painstakingly slow like this, with cameras and laser scanners to look at basically everything we've got that's delicate. We look at the results. The guys on the ground look at the results and gave Endeavour a clean bill of health. So that's like a big whew. You don't have to worry about that for the rest of the mission. Now, the next big thing is to go catch up with the space station and dock with it. It takes the entire crew of 6 of us to do this in a space that's built for 3. Some of our early views of the space station were like that. This is from the space station itself. These are the guys who are going to photograph our inspection run. So here we are showing the International Space Station, the Shuttle Endeavour for the inspection tour. This is sped up. It's not quite this fast. Everything we do is slow as paint drying. From the inside, we had station rise over the tail. The sun kind of got in the way, but still it was a spectacular sight to see this great big structure come into view like this as we finished our inspection flip. Once we finished that, we used the bore sight there. That's the target coming right up to the station. That's in feet, or inches, I mean. Okay, we're docked to the space station. That's a big process. So we open the hatch and we come on in and we find Earthlings. It's great. Found our friends on board, five folks on board, 2 cosmonauts, 3 astronauts, and one was Suichi Noguchi, who's a guy that I flew with on a previous mission, and we did our spacewalks together. So we're like brothers from another country. It was just great to be together. We had even a little welcome sign. Got right to work. Terry in the background and Kay in the foreground, pulling out Node 3 from the shuttle's payload bay, using this time the space station robot arm and plugging it in. And it took 2.5 hours to do what you just saw in the animation. It's very massive. You don't want to bump anything. And it's hard to start and to stop. And these are tiny little AC electrical motors in these robot arms. So everything is done really slowly. At the same time this was happening, the 2 guys were out doing a spacewalk. Of course, we told them to get out of the way, make sure they weren't in the seam here. But as soon as it was connected up, they got to work. Shortly thereafter, we pulled off the cupola off the nose and plugged it in on the Earth-facing side of Node 3. That was not without its excitement. We had some interference problems that we overcame. And there's the cupola in a protective sheath. It's still wrapped from the factory, and the spacewalker guys are going to go unwrap it outside. You can see how busy the space station itself is. This is another module that we had to relocate using the robot arm. This was a huge robotic mission as well as just about everything else. This was one of the most complex shuttle missions that NASA's ever flown. The wrapping, we brought it home. Yeah, we brought it in, brought it home. That's the airlock on the space station. Of course, the point of the airlock is you can't just open the door and go outside. All the air would go out. So you go into a little room, close it off, and open the door to that. But first, you have to get the nitrogen out of your blood. So you breathe pure oxygen. You lower the pressure overnight. Finally get in your suits. You stay in there for almost 2 hours, breathing more pure oxygen, trying to make sure the nitrogen is out of your blood so you don't get the bends. Finally, you get to go outside after being cramped up in that airlock. It's just a huge treat to open the hatch and float outside and into the big world and get to work with those big old pressurized gloves. That's part of Node 3 actually in the payload bay before we've taken it up there. And what Bob is doing is taking off the covers for those orange seals, which are responsible for keeping the air on the inside of the space station. Doing a spacewalk, almost everything is hard. Bundling up a cable is hard, tires your hands out. Putting it away won't stay in there. You know, gravity is the great organizer, and without it, things are a lot more difficult. You actually see how big the station is. Look up in the upper right there. That's one of the other spacewalkers walking along. I'm running them through their paces there, giving them step-by-step instructions. George was operating the cameras, and just mundane things like stringing a power cable from one module to the other takes quite a bit of work and coordination to get it done when you're doing a spacewalk. It's a dangerous environment. You really have to watch over your consumables. These guys look like they're fighting over a tablecloth at a picnic, don't they? It's actually sped up. What they're doing is pulling out a thermal shroud that they're going to put over those ammonia cooling lines. There's the ammonia lines. You can see the complexity of the operating conditions there. It can be really, really a big, messy tangle all the time. And it takes a lot of slow and careful diligence. But these guys put out 4 ammonia lines, big long ones, 15 feet long. For us, that's very long. And pressurized them with ammonia. They worked well. They only leaked a little. And wrapped them up. Went up to the cupola and started taking off the wrapping and on the brand new cupola. Felt like somebody's birthday, unwrapping this big, beautiful present. This is kind of the crown jewel of the space station in terms of the view. We had aluminum covers over the windows and all kinds of stuff to take off. Finally back in the airlock, big bags, big spacewalkers, hardly any room. And after 6 or 7 hours in there, they finally get to take off their suits and scratch their nose. All right, now the work on the inside begins because we can open the hatch. We've got cooling, which means we can add power. And to do that, we've got to hook up all the cables and lines. Now this is the number one off the factory floor for a Node 3, the only one ever built. So you can imagine it didn't go together quite exactly as planned. So we had lots of little surprises and interferences and things we had to sort of innovate around. While we were working inside, our colleagues are working outside. Occasionally we could see them. That was pretty strange, to be able to see your friend through the glass. That's the first opening of the hatch to the cupola. You can see how big it is across. Lots of electronics that is associated with the docking mechanism for those two modules that we then had to remove after its job was done. Communication systems with its own cooling. Various kinds of fluids, some of which are dangerous. So you got to dress up pretty well. Once we had the basic power and data, lighting and cooling to this module, Tranquility module, it was time to put it to work. So we moved in the environmental control and life support machines, like I said. So this is what they look like. They weigh over half a ton each most of the time, and they barely fit. We got it hooked up over several days, and we had a grand opening ceremony. It's like a brand new Walmart. All right, back on the shuttle. This is one of these don't try this in space at home things, or even in space. That was an M&M in there, and you try not to swallow M&M's whole. This is how a Marine fighter pilot does physics experiments. At least that's what I tell them. This is interesting partially for the trajectory of that small edible satellite, but also it gives you an idea of the environment. Of course, anything can become a satellite in space. And it's hard to keep track of all your food at all times. Sleeping is great. You can sleep on the ceiling, upside down on the wall like Terry's doing here. He's got his iPod on. You're strapped in because you want to wake up where you went to sleep. You need to exercise or your legs will get all skinny and pale like mine. This requires almost no explanation, I think. Just watch this. Peanut butter and jelly. Moving around in space, you can, if you're not careful, you can definitely get out of control. We were up there during this Winter Olympics, and we thought during a pass over Vancouver, Canada, we should join in. It was an international group up there, 11 of us from all over the world with several different cultures, several different kinds of food. And so we had a couple of meals where we all got together and spoke in our various languages and accents and shared food. And I think sort of the whole benefit of the international aspect of the space station really came true for us crew members. Well, eventually, sort of the reward for doing all this hard work was getting to open the windows on the cupola for the first time ever. The moon was in that phase. That's about 2 phases ago, or 2 cycles ago. And this is the kind of thing you could look at. Like I said, these are not very professional. They're just home videos that we took in our excitement to kind of share with folks back home what we could really see. We could see more of the Earth through these windows by far than any other window on either of the spacecraft. And sunsets and sunrises last. They're very quickly. I'll show you a sunrise here in about 20 seconds or so. It's spectacular to watch from these windows also. I mean, I could talk about it till you're tired of it, maybe you already are, but you cannot describe how amazing it was to see space from that aspect. Well, we got our work done, and it was time to go home. We said so long, we closed the hatch, and we backed away from the space station. You'll see the separating point between the shuttle and the station right here as we separate. This is done by hand.
Pedals clear, I'm LB late.
So now it's Terry Burt's job to fly, and he's flying by hand to move out away from the space station and then circle it. We watch the sunrise like this. Goes through kind of this toasty orange color. This is real time. And very rapidly up to a bright, almost acetylene white. So we did one lap around the station taking inspection photos. One of the big things about that environment is there are bits of debris in space, and if they hit the space station, and they do, we want to know where they are. So we went all the way around. We had a fabulous daylight clear pass over the Himalayas, which in my experience, you almost never see the Himalayas in that much, with that much clarity, lack of cloud cover. Kind of admired our handiwork a little bit here, and also took a real good close inspection of the whole structure. So now it's time to get Space Shuttle Endeavour ready to go home. There's stuff everywhere. It's kind of like going camping for a couple of weeks. You have to pack up. Now, where did I put this, and how come this doesn't fit where it was when we brought it? It was like that. We closed the payload bay doors. Very structurally important. We got back in our suits. Now, this is harder than you think because I grow about 1.5 inches in space. Your spine stretching out. So getting back in your suit is really painful. It doesn't fit anymore. And back down into the atmosphere, like I was talking before, you're hitting the upper reaches of the atmosphere so hard that the molecules are releasing energy through photons. And they glow in this amazing flashing plasma. It looks like pink flash bulbs going off in your cockpit. All the way back down to Florida. Weather was great. We landed, I think it was around 10:30 at night. George Zamka at the controls. This is done manually. It's only his second space shuttle flight ever, and he's landing the shuttle. No pressure. Did a beautiful job. Chute comes down to slow us down because we landed almost 200 knots. You can see kind of a little flashing there. That's the exhaust for our hydraulic motors that power the aerosurface controls. Every pilot wants to land right on the center line. George managed to do that. And we're standing here trying not to fall over. I'm going to go back to a couple slides here just at the end. There's our patch kind of came true. Okay, back over to the center screen just for a couple. This is a picture taken from the space station crew just as we pulled away. What's that in the window there? If we take a closer look. Guess who? And then, of course, UC Davis is a very important place to me, and College of Engineering really gave me the opportunity to pursue this. And so it was nice to remember. So thanks very much. I think we have time, but not very much, for some questions. So we'll start with that.
First of all, I'd like to say, from our perspective, my husband and mine, that we have enjoyed all of your public talks so much on campus. It's been fascinating, so thank you very much.
Thank you.
My question is, given proposed cuts to NASA, what do you foresee as the future of the space program?
That is a huge question.
I'm sorry.
No, it's the right question to ask, too. It's the one all of us are asking ourselves and each other every day. First, let me frame it a little differently. The question is, due to proposed cuts in the NASA program, where is the future of spaceflight going for humans in this country? We had a kind of a forum about that in the hour before this talk. just to discuss it, not to answer that question. The proposal on the books, on the table from the White House, is to increase NASA funding, but to not go back to the moon as we planned. To use that funding to do technology development, advanced technology development for traveling in space, both near and far distances, particularly for large rockets, and also to promote other companies or companies outside of the U.S. government to develop the capability of taking humans to the International Space Station. Everyone believes all those are the right things to do. It's a matter of time. If we retire the Space Shuttle in September as planned, which is probably going to happen, how long will it be before Americans can launch in space and go to the space station? And the question is, well, not long at all if we buy seats on the Russian spacecraft, which we are doing. We have been doing, in fact. Tracy went up on a Russian Soyuz rocket, and we'll continue that. But for the foreseeable few years, that will be the only way that Americans can get to the space station. That may or may not be the best solution in the world. And there's an awful lot of jobs involved, too. So these are really big issues that have large economic impacts and therefore large political impacts. There's, the president is going to be down at Kennedy Space Center next week to discuss these things. And I think that that will be pretty educational to find out what his point of view is. Now, of course, the president proposes a budget and how it is going to get used. NASA is an agency and marches to the policy decisions of the White House, but the funding comes from Congress. And Congress is supposed to listen to us. So, write your congressman on whatever it is you feel. Yes, Gabriel.
Can you contrast the SpaceX program with the canceled Constellation program?
Oh, probably not. You know, in the last year, when the question is the SpaceX company is building, proposed and is in the process of designing well, both a rocket and a capsule that will take first cargo and then people up to the space station. Man, that's the right thing to do. That's the right thing to do. What I can't comment on is the particularities of their engineering approach. Mostly because I've been training for this mission for the last now year and a half, so I don't know those kind of details. I know that all of us hope that they really succeed and that they can do that kind of thing more reliably and cheaper. But reliable and cheap are at odds with each other. That's the whole problem with spaceflight. There's somebody over here. You're not over here. You can go.
Do you want to go back as part of one of the International Space Station expeditions?
Do I want to go back?
Yeah.
Anybody who's been in space probably wants to go back, and I do too. But after 4 missions, I'd be a little surprised if they gave me a 5th when other people are waiting for the 1st and 2nd. We'll see. Way back in the corner there, young man.
How long does it take you to build these ships? Because it kind of looks like a giant Lego set.
Giant Lego set. Why didn't anybody ever think of that?
How long does it take you to build them?
The one you saw right there has taken 12 years.
Whoa,
12 years, yeah. It's a big Lego set.
What's the anticipated service life once it's up there?
The anticipated service life for the space station, well, it's all money, you know. It was initially talked about to 2015. Now I think it's pretty well understood that we'll go at least till 2020. Personally, I hope and would go further than that, and would be surprised if it did. The investment has been pretty massive. It's working really well. You know, I mean, this space station was put together from engineering outfits all over the world and was brought up little bit by little bit and put together, as you saw, painstakingly with robot arms putting together, and every single piece went together. We never had to bring another one home, bring a piece home that we brought up because it didn't fit. That's amazing. That is amazing. That's the combination of engineering diligence and international cooperation that I just don't think this world has ever seen before. One of the biggest benefits of this whole program. Okay, agree.
How far away are we from landing a human on Mars?
How far away are we? I bet you mean time and not miles. From landing a human on Mars, that sure depends on who you ask. I think about 40 years. Yeah. Because there are some problems that are really hard to solve. I think we've proven we can live in space for that long, you know, for roughly a year or so. There are challenges. We're still learning about human long-term adaptation to microgravity for sure. We haven't got it all figured out, but I think we can do that. But let me give you an example of a really hard problem, radiation. You get away from the Van Allen belts, what are you going to get? You're going to get a full hose radiation. What's the best way to shield yourself from radiation? Something very dense, right? Density means weight. Weight means rocket propulsion thrust used to get it up there. And it not only has to go to Mars, it has to come all the way back with you. Big problem. And the old problem of if you go all the way to some distant destination that doesn't have any gas stations, how do you have the gas to get back? You have to manufacture it there out of local resources, which takes a whole bunch of stuff you have to take there as a manufacturing plant, or you have to take the fuel all the way there that you're going to use to come back. These are some of the major engineering challenges that I think we're going to face. These are not one-decade type problems. Yes?
Are there any really promising commercial applications for the International Space Station that are being talked about now?
Yeah, there are. The pharmaceutical companies are starting to get more and more active in terms of things like drug delivery and protein structures. You know, you build protein crystals can grow very large and more easily analyzed in space. So you grow them in space, bring them back, and you can learn about the structure of a protein and its geometry is the way an engineer thinks about it. I think that there's some material science issues in terms of making things very spherical. That not so much that we will manufacture things in space, but there will be a theory that if you go to space and you can make something more easily, you can then determine, you know, get the results, bring it back home, find out if that really provides the benefit that you had intended, and then say, aha, it's worth building some sort of ground facility to get this benefit. So it's kind of a multi-step process, but that's really how the benefit works. But then the tangential aspect benefit, I think, to all of us of going to space is the fact that you generate technology in trying to do this that you wouldn't have generated otherwise. That may in the end have nothing to do with spacecraft or you flying in space, but can change our lives in very significant ways. And that surely has happened in the last 40 years. We're running out of time. I'm going to take one more question. Can I take one more? All right.
Why don't you bring like a tree into space so you have more air?
That's a good question. Why don't you bring a tree into space since you have more air? Because what do trees do? What do they use to build their own?
Air.
Well, they use carbon dioxide, right?
Yeah, but in a spaceship, so you have
And they
more
generate
air.
oxygen. Well, we haven't learned to do that yet. It's a great idea. We haven't really learned how to do it. We've tried a few things. The cosmonauts showed me some, I think it was a wheat grass that they were growing in space. And so there were actually some plants on the International Space Station. There's more plants on the space station than there are in my house, at least live ones. But that's a great idea.
Well, let's
Bruce?
thank our special guest today.
Thank you, Bruce. Appreciate it. Very nicely done. Good. Thanks a lot for having me back. Ah, okay. Okay, good. Good deal.